Today we're gonna discuss how the lab investigation is working. We can have more classifications of lab investigation tests, right? And these classifications can depend on type of pathogen, can depend on purpose we have, can depend on security level we should have. For example, if we are saying that we want to classify according to the type of pathogen, we can have bacteriological investigation, yes, virological, mycological. If we are talking about purpose of investigation, sometimes the purpose can be clinical, that means diagnostic, yes? Sometimes it can be, the purpose is studying. For example, what we are doing here in the department. We make some investigations or we make some reactions, not to find out the pathogen, but just to learn how to diagnose. Also, the reason can be, bless you, the reason can be scientific. So we don't have any patient with the disease. We don't have any need to learn how to make some investigations. But we want to find out something about some pathogens or about some microorganisms. It is scientific purpose. Also, it can be in dependence on level of security or level of danger that presents any pathogen. So you should remember from the last year levels of biosecurity. Do you remember? BSL 1, 2, 3, 4. No? In dependence on how dangerous is the pathogen we are working with in the lab, we have different levels of biosecurity. So biosafety level number 1 is here in the department, because we are not working with pathogens, we are working with non-pathogenic or conditionally pathogenic flora. Biosafety level number 2, it's, for example, any clinical lab in polyclinics, in hospitals, in general hospitals. BSL 3, specialized labs. For example, tuberculosis lab. It is here nearby, near the Republican Diagnostic Center. Because tuberculosis usually is spread through the air, it is pretty aggressive infection. So it is pretty contagious infection that spreads fast. This is why, and it is very resistant in the environment. This is why we need to apply more security measures in order to not allow spreading of pathogens from the lab. BSL, it is BSL 3. And BSL 4, if we are talking about BSL 3, either tuberculosis, either flu, COVID, and so on. Such labs should have biosafety level number 3 with special equipment, personal protection equipment, like in pandemic we used, special filters for entering and exit from the lab, with shower before and after the work, with the active ventilation, with filters and disinfection and sterilization. Very high security level. There is no big difference between biosafety level number 3 and 4. So biosafety level number 4 is also even as secure, even more secure than BSL-3. But there, the staff is working with not just extremely contagious. Flu is extremely contagious. COVID is extremely contagious. Tuberculosis is highly contagious, not extremely contagious. But there are some infections that are extremely contagious and at the same time extremely dangerous, extremely aggressive as nosology, as disease. So all of us, we had flu in our life, or any other viral respiratory acute infections. But fortunately, all of us are alive, yes? But there are some extremely contagious infections, not that much, but still we have such contagious infections, extremely contagious infections, that have very high rate of severe forms, and as a result, very high mortality. So with such infections, we must work in BSL lab number 4. As well as I know, we don't have in our country yet BSL number 4. And my dream is to not have. Why? Because it would mean we don't need it. That's enough. We have BSL number 3, BSL 3, because we have flu, we have tuberculosis, we have extremely contagious, but we don't have extremely aggressive, highly contagious infections. Now, in all of these labs, we are using different methods of investigation, different methods of lab investigation. It can be microscopical, it can be bacteriological or virological, it can be serological, it can be molecular biological, it can be... what else? Mostly this. And here is my question. How do you think which of them is the mostly let's say the mostly appropriate? No. Which is the best one? Which is the best type of lab investigation in your opinion, and why? Microscopical, bacteriological, virological, serological, molecular biological. Which one is the best one and why? Please, opinions. Opinion cannot be wrong. The answer can be wrong. The opinion cannot be wrong. So don't be afraid to give your opinion. Huh? Serological. Please explain. Antigen to detect? Antigen to detect what?
Which type of bacteria?
Antigen to detect antibodies and antibodies to detect antigen, yes? Okay, why do you think it is the best one? Why? Or you just like it?
which type of bacteria depends on the presence of antigen.
Okay. So it is. Huh? Okay. It is faster, or it is more precise, or it is cheaper, or it is, or altogether, or what? Why you consider it to be the best one? Because by using, for example, electron microscope, we can find the same features, but in different way. So why? Huh?
It's cheap.
It is cheap. It's very good answer. It is very good answer. It is cheap. Is it fast? Yes, it is fast. Is it precise? Huh? Yes, it is. So now we have we have a healthcare system that is looking for the best option. Yes, and the healthcare system is looking for what? For the mostly expensive? Why? Why should they look for the mostly expensive? Even on the legal way, one of the conditions in public acquisitions, in public purchase, is to choose the cheapest position. That's sometimes basically it is good, but sometimes it doesn't fit to other conditions. And if the price is the first priority, not every time it is a good decision. But basically it is very important if you have the solution with same features and same quality and it is cheaper, of course we should look for a cheapest one. Okay. It is fast, it is cheap, it is precise. Do you remember in the beginning of pandemic how much was to make PCR test? No? Did you make any PCR test during pandemic? I guess not once. Yes? And do you remember how much was to make an antigen test? What was cheaper? Antigen test. And what was faster? Antigen test. And what is more precise? PCR, a little bit. Like PCR is about 95% precise and antigen is about 80% precise. Are you okay with 80%? I'm okay with 80%. Why you are not okay with 80%? You want 100?
Yes.
Do we have any? Do we have any method that gives 100%? Okay, let's talk about vaccination. Do you remember a lot of people wasn't agree with 65, with 80, with 95% efficiency of vaccine? Do you remember? Everybody and specialists were saying, guys, come on. Every year we get anti-flu vaccine and its efficiency is not higher than 40%. And you are still okay with that. And people were saying, yes, but it was produced too fast and we cannot be sure. Guys, every year we have a new vaccine against flu. New. It is not the old one. Every year we have a new vaccine against flu. And its efficiency 40%. And we still get this vaccine and it still protects. So, from this point of view, 80% precision of a test, for me, is a good option. Now, Now it is not like you make a test, you make antigen test, it gives you a positive result, and you say, yes, but just 80% precise. I would rather check by using PCR test. And you're making PCR test and it is negative. Which one you will trust? PCR or antigen? Who would trust more PCR? Who would trust more antigen? Who wouldn't trust? Who would trust both of them or wouldn't trust both of them? Now, the truth is that in case you already have a positive result, you don't need any other checkup. It doesn't matter is the general precision of the test 80 or 90 or 100%, even if 100% doesn't exist. If we already have a positive result, we don't need another test. Why? Because we have such option or such result as false negative result. It can happen. And we discussed about that last week, right? It can exist. A false positive result usually is either because of fault of the medical staff during collecting sample. The sample wasn't collected in proper conditions, so we didn't succeed to find the pathogen. Well, the person is infected, but I didn't collect the sample in a proper way, so basically I didn't get any pathogen. And of course, in the test I will have negative result, but it doesn't mean the person is not sick. Either because of patient who washed itself too much, or simply the patient already has symptoms, general symptoms, but the elimination of pathogen didn't start. So we make the test, we don't have a positive result. It doesn't mean the patient is not sick and is not infected. That means we can have false negative results. We also can have unclear result. When when the test is made of bad quality and something is wrong in the contents, in the structure of the test, so it is not able to show one or two strips. In this way, sometimes you cannot understand, is it positive or negative or what it is. Such cases we also could have. But it is almost impossible to have false positive result. Yes, we could discuss and I could explain some conditions in which we would have false positive result, but in real life, technically, it's very hard to imagine it to happen. Like using same swabs for more patients or something. In real life, it doesn't really happen. If it happens, sorry. We should close such a medical institution in which it could happen, right? We should make investigation with very bad consequences for such stuff. Moreover, there is a higher chance for having a false positive result in PCR test than in antigen test. Why? Antigen test usually is a single-use kit. Yes? And PCR test is a machine. And if you are trying to make more tests at the same time, I mean in the same day, you are trying to make more tests than it is supposed, there is a chance you will not disinfect properly the machine. The biological material from previous patients will persist in the machine, and when you will put new kits, you can have false positive result, because genetical material from previous tests will persist in this machine. So if you break the rules of using of this device, there is a chance of having false positive results. So in such cases, when we have overload of the lab, I would rather trust more antigen test, not PCR test. But anyways, I decide to trust my colleagues that they don't break the rules of the lab functioning. And I really have some colleagues who are working there, and they told, yes, it is possible if you break the rules. But the consequences are too bad for us, so we wouldn't like to get in such situation to break these rules. This is why I'm more supposed to trust them, that everything is okay. This is why it depends. If you have unclear result of antigen test and you want to check it out by using PCR test, makes sense. If you have a negative result but you have symptoms and you are not sure, you wait a little bit and you either repeat the antigen test, either send the patient for a PCR test. It makes sense. But if you already have a positive result, it doesn't make any sense wasting tools, wasting materials, wasting the medical staff time. All of these are wastes. So we shouldn't waste our materials and our time and our resources. This is why you should keep in mind that even if it could happen technically, in real life, almost never we have false positive results. So we decide to trust positive result. It doesn't matter which type of investigation we apply. Now, do you remember the dynamic of prices for tests? In the beginning, it was almost impossible to take the test by any price, because first tests, we even didn't have kits for tests in our country, so we needed to send first samples in Germany via DHL. And next day, in the best case, we had the result of PCR test. After that, first 100 tests arrived in our country. What is for 100 for a country, not too big country, but still up to 3 million population, 100 tests during pandemic. It's nothing. But how much media were talking about these 100 tests? After that, we started making our tests. So, closer to the end of the pandemic, price for PCR was moving from 100 euro per test After that, about 50 euro per test. After that, about 30 euro per test. After that appeared antigen test and antibody test. So antigen and antibody test were starting with about 25 euro per test. After that, about 20, about 15 euro per test. And now, in any pharmacy, you can buy antigen test for COVID with 2 euros, one test. And you can make it yourself. And it is pretty precise. So you can be sure without going in the lab and paying and waiting. In 10 minutes you have a result on your own. If you stretch your brain good enough. Yes? Why it happens? Why it happens? How do you think? Somebody is making money on us? If we will start with conspiracy theories, we can suppose. But the reality is that if something is rare, it is expensive, yes? If something is common, it is cheaper. Guys, you can imagine if some of you have a car. If it is a rare car, parts for this car will be extremely expensive. And it doesn't make sense. It doesn't make too much sense, especially if you cannot afford a rare car. It doesn't make sense to have it because you need to keep it working. At least you want. So it will be extremely expensive. If it is a common car, like Toyota or something like that, and you can find it anywhere, you can find cheap parts for this car. Everywhere. Same thing happened during pandemic. In the beginning, it was extremely rare because this type of virus appeared just now. So we start production. In the beginning, we didn't have that much cases. That means we didn't need to produce a lot. If we don't need to produce a lot, the cost of production of one test will be bigger, right? If we produce a lot, the cost of one piece is lower. So as much pandemic we're developing, as much production amounts increased, and the price, the cost of the test decreased. Excuse me. Okay. Now, talking about these different types of investigations, we can say serological test is cheap, is fast, has high precision. Why don't we use just this one? Just this one? Why don't we use just this type of investigation? Huh? Would it make sense to use just serological test for any kind of infection? Yes or not? Why?
Trusting the serological test will make sense.
Okay. And that's right. And also, if we are trying to use just serological test, what it means? Serological test is very specific. That means for any type of infection, we need to have specific test, right? We need to have a specific test for any type of infection. Is it possible, technically and financially, even if it is cheap, to have any test for any infection? First of all, it doesn't make sense. So if for our region, specific infection is more common, we will have in our stocks enough tests for this specific infection. But if we have some cases of import of infection from another region, for which this infection is more specific, but for our, it is considered exotic infection, yes? It doesn't make sense for me to buy all types of tests just in case of. And for such cases, we are using non-specific tests. One of classification of investigations in microbiology also is specific and non-specific. So microscopical investigation is a non-specific one, right? You can apply the same microscopy for any bacterial infection. Of course, we cannot apply simple light microscope for viral infection. But for any bacterial infection, we can apply light microscope. We just make different types of staining. So we have it. And we can, in the beginning, to differentiate at least the direction in which to look for. And if we can see that our suspicion regarding the infection is showing us we are in the correct way, we can start looking for specific tests like antigen, antibody. But if not, we are looking for another solution. Is it gram-positive or gram-negative? Is it acid-fast or not? So microscopy sometimes is enough. In some cases, it is just start. It is just first level filter that will help us to make, differential diagnosis and to put aside all the wrong variants and to move forward to the correct one. But sometimes on the first step, we already have the right answer. And usually it is about the mostly common infections, like staphylococcal infections, like streptococcal infections, like tuberculosis, like diphtheria, like the mostly common infections can be discovered and can be confirmed very often just by using microscopy. So it costs almost nothing, even less than one serological test. Makes sense? Yes. So it depends, it all the time depends on situation. It all the time depends on our needs. And sometimes it will cover our needs, and sometimes we would need to look for something different. Now let's remind, we have two main directions in serological investigation. Serodiagnosis and seroidentification, right? Which is the difference between serodiagnosis and seroidentification? I guess we discussed it last week, no? Somebody says yes, somebody says no. Which is the difference between serodiagnosis and seroidentification? In both cases, we have reaction between antigen and antibody. The same reaction in some circumstances can be serodiagnosis, and in other circumstances can be seroidentification. How it works? Serodiagnosis is looking for unknown antibodies by using known antigens. That means we take known antigens from our lab. An antigen usually is either pathogen, either it's particle, right? We take antibodies from patient. We suppose antibodies of patients are present in. What do we take as a specimen from patient? Blood. Mostly antibodies are present in blood. We take known antigens, we take blood with unknown antibodies, but by symptoms we can already start supposing which infection we have. This is why we take antigen not like this, just Russian roulette. Today we'll take brucella or staphylococcus or something else. We suppose by symptoms. It could be staphylococcal infection. That means I take antigens of staphylococcus, maybe aureus or something else, or I'm taking antigens of another pathogen. I take the blood from a patient. I make serological reaction. If reaction happens, that means antigens fit to antibodies. Reaction is positive. That means I confirmed the diagnosis. Yes or not? No. Why? Why not? Because presence of antibodies not all the time proves presence of pathogen. Presence of antibodies will prove you that person either is sick now, either the patient used to be sick recently or a long time ago. It depends, IgG, IgM. Yes? If IgM antibodies, that means it is acute process or recent process, inflammatory process. If IgG, that means it is either chronic process, infectious process, either it was long time ago. So, it will show us if the patient is immune for this infection. If our body produced antibodies for this infection, it will indirectly prove us presence of infection now or in past. If we want to make diagnosis, we apply sero-identification. And sero-identification means we take known antibodies from our lab, and this time we appreciate also by symptoms. We take a sample from patient. Which sample we take from patient? What do we take from patient? Blood? Maybe blood, maybe not blood. How you decide what you take from patient? By symptoms. So, which symptoms should have the patient in order I would look for antigen in blood? Huh? Allergy? If we are going to make allergic reaction, yes. But if we are talking about infectious diseases, no. Fever, and when we are talking about fever, which kind of fever you are expecting? What is fever? What is fever? What is fever? Huh? It is body temperature, increased body temperature by intrinsic factors over 38 degrees Celsius. But if we suppose a pathogen in the bloodstream, it is even higher fever. For sure it will be over 38 degrees Celsius, but probably it will be over 40 degrees Celsius without possibility to decrease it by using antipyretics. So if we tried to decrease fever and we didn't succeed, we can suppose we have a pathogen circulating in the bloodstream that can lead. It can be viremia or bacteremia, it depends on pathogen. So we apply this investigation because it can lead, if it is bacteremia, it can lead to sepsis, septicemia. And this stage can already lead to death very fast. So in this case, indeed, we are taking blood. But such cases you will not meet too often. Much more often you will take another specimen from patient. Could you give me other examples of more common specimens? Did you ever make antigen test? Yes, of course. Did you ever make antigen test? Yes, of course. Which test? Huh? Antigen test. COVID test. So which samples you... Nasal swab. Why? Because the pathogen is there. So how you decide which specimen you take? By symptoms. So if we have respiratory tract issues, we take the sample from the respiratory tract. If we have intestinal infection, we take samples as sample stools. Or sometimes maybe vomiting masses, or sometimes maybe rests of food. And we can check it out for presence of a pathogen by including antigenic test. Because antigen is a particle of pathogen. And in these cases, we can make very fast diagnosis. The fastest diagnosis ever is made by antigenic test. What else? Also, we can have another classification. We can have also another classification of investigations that is called quantitative and qualitative. Which is the difference? Which is the difference? We have rapid tests, yes? And we have a little bit longer tests. For example, rapid test, it is something it is a kit you can buy in a pharmacy. It looks like COVID test, it looks like pregnancy test, if you ever saw it, yes? You put the prelevate in the recipient and 1 or 2 strips will appear. It is classical appearance of any fast antigenic test, right? So, is it quantitative or qualitative? Huh? How do you think? How do you think?
Maybe by the number.
Huh?
It depends on.
It depends on number of what? Hmm? Express test is just confirming or infirming. Fast test is just confirming or infirming. That means it either confirms, either doesn't. Now, we have a little bit longer antigenic or antibody test. For example, you go to a lab, you are giving blood for detection of antibodies, of immunity. By using express test, usually you will see just presence of antibody. Either they are present, either they are not. Some antibody tests, express test, they have, instead of 2 stripes, they have 3. One is control, second one is IgM, and the third one is IgG. So this test will show you presence of both recent and chronic infection, like IgM and IgG. Now, when we are making more specific test in the lab, not express test, they can look for how much antibodies, how high is the titer of the or amount of antibodies in our blood, because they can be present, but their amount is not enough for protection. In such a case, we can recommend vaccination, yes? But if the level of antibodies is high enough, we don't need vaccination, we can say. But it is quantitative analysis. It is quantitative test that shows us amount of antibodies. Next, it can be qualitative, because antibodies can be different. Some antibodies are just showing presence of pathogen, and some antibodies, they have really ability to neutralize the pathogen. So one more interesting thing about antibodies, not all of them are able to neutralize the pathogen. So which kind of antibodies we have? Neutralizing or non-neutralizing antibodies? Because antibody is just response of presence of antigen. But by binding some antigens, antibodies are able to neutralize the pathogen, but by connecting to another antigen, they do nothing to this pathogen. As a result, no result, no protection. So these two will be quantitative and qualitative assay. Of course, each of them is applied for different circumstances, for different situations. This is why we have that big number, that big diversity of investigation tests, to have different tools to work with. Some tools can be universal, but will not be as precise. Some tools will be specific, will not be universal, but their precision will be much higher. This is why it is extremely important to collaborate with your colleagues from the lab. They will help you to provide the best treatment. Okay? Okay. Questions? No questions.